So this is an add-on to Notes 10. It's something I've talked about, but I want to kind of put it together. This top line is a true statement. Square root of something is the same as that something raised to the 1/2 power. Now, you know that you cannot distribute exponents to two terms. So these two things are not equal, okay? So x squared plus y squared raised to the 1/2 is not going to be x plus y, okay? So we know you cannot distribute exponents to terms. But since exponents are, fractional exponents are radicals in disguise, the same rule holds. You cannot split a radical along terms. These two statements are not equal. So you cannot split a radical along terms. Splitting a radical along terms is the exact same thing as distributing an exponent to terms. So both of these are very easy, common mistakes. And I know I was teaching pre-calc some years ago, and students were doing this really hard word problem, got this really great answer, you got it. They got something like this, and then they split it. Split the radical along terms and then blew it at the end. So really basic things that you need to remember right here. You cannot split radicals along terms. You cannot distribute exponents to terms. It's the same idea. So now I'm going to do Notes 10, page 4. So listen to the instructions here. I know I do some problems like these on assignments, and then people don't read the instructions. We're going to leave the negative exponents. Okay? Sometimes negative exponents are a lot easier to work with. Man, if you have to take a derivative, you'd much rather have a negative exponent than have to use the quotient rule. So this problem doesn't have any negative exponents, but if we come across them, we're going to leave them. So we're going to factor completely. Again, we have fractional exponents, keep to exponential form. Now, what is the first step in factoring? Look for a GCF. Okay. Well, there's no coefficient that divides into all the terms, and there are 3 terms here. But there is an x common to every term. How many x's common at most? Well, the x with the smallest exponent. So the GCF is x to the 1/3. All right? So remember, when we take out a GCF, we write it in front of one big fat blank parentheses, and we basically ask x to what, times what will give me x to the 7/3 back. X times what will give me this term back. X times what will give me this term back. So, so what we're asking here is x to what power? What has to go there? Well, I know that when I multiply the same base, okay, I'm doing some scratch work over here, I add the exponents. So I'm basically asking 1/3 plus what would give me 7/3? Well, you could just think about it. That would be 6/3. So I'm going to write in the 6/3, and some of you are realizing, well, that's just 2. You definitely want to change that to 2, but for right now, I'll write in the 6/3. Then x times what will give me this term back. I obviously need the -3. The real question is what exponent? So again, I'm asking, just scratch work over here, x to the 1/3 times x to what power would give me x to the 4/3? Well, I know when I multiply the same base, I add exponents, so I'm really asking 1/3 plus what gives me 4/3. And some of you might see it's 1. Some of you might first see it's 3/3. 1/3 plus 3/3 is 4/3. So that's what I need for the exponent on x. And then the last term is easy. X to the 1/3 times minus 4 will give me minus 4x to the 1/3. Now, this is a great beginning, but you will not see what to do next if you don't realize 6/3 is 2. And I've had students do that, and then they don't know what to do next. So we really do need to write this as x squared minus 3, and this is 3/3 is just x to the first minus 4. Now I see what's going on. That looks like a FOIL problem. So I think I can factor that. It looks pretty easy. No pattern. It's definitely x and x. I'm running out of room though. And I think it's going to be minus 4 plus 1. Hopefully that's not hard. You look at it, outer is plus 1x, inner is minus 4x. Add those together, you get the minus 3x. Check the sign of your last term. Negative 4 times a positive 1. Yep, that'll give me negative 4. All right, so try the next one. Now remember, you're going to leave the negative exponent in the problem. So give it a try, pause the video, turn it back on when you think you got it. If that negative exponent's really throwing you off, I'm going to go ahead and start this right now. So we're going to factor, leave the negative exponents. So let me draw a line here. So there's a lot of clutter in here. First step to factoring is the GCF. All right, so look at the coefficients. 2 goes into both of those, so that's 2. Look at the variables. Yes, there is a variable common to all terms, an x. But x to what power? Well, of the exponents, the smallest exponent is the negative 1/2. So we'll use that as our GCF. So when you do a GCF, you write it in front of blank parentheses. And you basically say 2x to the negative 1/2 times what will give me this term back. The GCF times what will give me that term back. The GCF times what will give me that term back. So let's see what we get here. Well, 2 times 2 will give me the 4. And then obviously I need some x's here because I got to bump that up to 3/2. What exponent should it be? Well, do some scratch work over here. I'm asking x to the negative 1/2 times x to the what would give me x to the 3/2. So remember, when you're multiplying the same base, you add the exponent. So I'm really asking negative 1/2 plus what is 3/2. And many of you might foresee that as, oh, I need 4/2. Now, if you see that as 2, go ahead and write down 2. But a lot of you might just write down 4/2 because that's the easiest thing to see. All right. Now, 2 times what gives me 42, that'd be 21. Then x to the what power? So here, I'm asking x to the negative 1/2 times x to the what will give me x to the positive 1/2. And I know, again, that when I multiply the same base, I add the exponents. So what I really need to know is negative 1/2 plus what gives me positive 1/2. And that would be 2/2. And again, if you just see that, oh, that's just 1, go ahead and write that down as 1. I'll first write it in as 2/2. And then this one's the easy one, plus 10, right? Because the exponent's the same, so I just need to know 2 times what gives me 20. All right. So a lot of people will start this way, and that's a great start. But again, students don't recognize 4 halves, that's just 2. And you have to recognize that to see what to do next. So this is really just 2x squared plus 21x plus 10. Okay. And then when I look at that, I realize, that sure looks like it comes from FOIL. So let's see if we can factor this. Bring down my GCF, open my blank parentheses, fill in everything I know. Well, I know it has to be 2x and x. I know everything's positive. Okay. And last times the last, it's either 5 times 2 or it's 10 times 1. And you cannot put a 2 here because that would create a GCF that we already pulled out, so there shouldn't be another GCF. You cannot put a 10 here because that would create a GCF, and we already took out the GCF. So I'm kind of looking at that big 21. So I'm thinking if I put the 10 here and the 1 here, outer is 20x plus 1 is 21x. Yeah, that's it. Okay. All right, one more problem on this page. So remember, this is factor. So I want you to factor this. So pause the video. This one's actually pretty easy. I'm actually leaving an easy one for you. Pause the video, check your answer. All right, so we're gonna factor this. Always look for a GCF first, and there is one tricky thing. Okay, there's no coefficient that divides into both of those, no number that divides into both coefficients, but x is common to both terms. And the common mistake is to think, oh, I'll take out x to the negative first. But remember, with the GCF, we use the smallest exponent, and negative 2 is smaller than negative 1. So you're much better off if you take out x to the negative second as your GCF. Okay, open your blank parentheses. Okay. Then you ask yourself, x to the negative second times x to the what would give you x to the negative first back? Well, we add exponents negative 2 plus what would give you negative 1? That would just be 1. Think about it. Multiply these out. Multiply the base, multiplying the x's, add the exponents, negative 1. And then it's just plus 2. And I'm going to get rid of the box. I don't know what I'm doing there. Get rid of the box. There's it. That's it. That's the answer I want. Done. You leave negative exponents. Okay. Now I just want to show you something. Compare this answer to what if I'd asked you to remove the negative exponents and add these two? Well, x to the negative first is 1 over x plus 2x to the negative second. Now the only base that has a negative exponent is the x, so that goes down as x squared. The 2 stays on top. Now we haven't really covered this, but I think most of you have seen this. We have to get a common denominator for these fractions, and the LCD is x squared. So I can multiply this fraction here by x over x. I get x over x squared plus 2 over x squared. And once you have a common denominator, you just add the numerators. There's the answer. X plus 2 over x squared. Okay? Now, check this out. How does that compare to our factored answer? What if you take our answer and you remove the negative exponent? Well, this will drop to the denominator of this term. The x plus 2 will stay on top. And notice, by factoring out that negative exponent, we essentially added these two terms in a sneaky way. Because, I mean, when you add fractions, you start with two terms and then you get a common denominator. Your final answer is one term. When you factor, you start with multiple terms. When you factor, you wind up with one term. Okay, and then that GCF with a negative exponent happens to be the common denominator. There are a lot of connections to all the different simplification techniques that we do.